Gujarat recently committed to a massive new energy target, 150 gigawatts of renewable capacity by 2035. This is the volume of power needed to sustain the state's current economic trajectory. Meeting this target requires land, capital, and a specialized workforce at a scale rarely seen in civil engineering. The logistical requirements are staggering. Hitting 150 gigawatts means moving beyond the standard solar farm model to concentrated mega-engineering. The site for this project is a 72,600-hectare wasteland near Vigakot, Kutch. It is a harsh, remote salt desert, nearly devoid of existing infrastructure. The government's plan involves an $18 billion investment to convert this specific desolate site into the Gujarat Hybrid Renewable Energy Park. This facility is designed for a final output of 30 gigawatts. On completion, it will stand as the single largest power plant on the planet. This project demands a custom infrastructure ecosystem, a massive logistical network built from the ground up in the middle of a desert. To understand the 72,600-hectare footprint, compare it to a major metropolis. You could fit the entire city of New York or London inside this park. The density is equally extreme. Installing components for 1/30th of the capacity required 2.4 million solar modules. Large-scale solar arrays form the base of the park's energy production, stretching across the salt flats to the horizon. Engineers integrate a massive wind component alongside the solar panels. This hybrid approach captures the Kutch wind currents without requiring a larger land footprint. Combining these two technologies maximizes the output of the wasteland, though it creates a high level of logistical complexity during construction. Generating 30 gigawatts of electricity in a remote desert creates a massive logistical gap. There is no existing system to carry that power to distant urban centers. Foundational work began with a 30-kilometer heavy-duty access road carved through the desert just to allow construction crews to reach the site. To bridge the distance to the grid, the Ministry of Power allocated roughly $2.2 billion for these massive steel transmission pylons and high-voltage lines. Even that $2.2 billion grid investment is only designed to handle the first 7 gigawatts of power. The remaining 23 gigawatts will require further expansion. The engineering challenge of mega-renewables is often the financing and construction of these high-voltage highways required to carry the current. Executing $18 billion in remote construction requires an immense mobilization of human capital. This project is the driver for 100,000 direct and indirect jobs, ranging from manual labor to specialized technical roles. The workforce profile ranges from heavy civil engineering and rebar placement to the high-tech management of advanced grid systems. By creating 100,000 new roles, the project functions as a massive socio-economic catalyst for the surrounding Kutch district. By the slated completion in 2029, the park's output will be enough to power 18 million Indian homes. Environmentally, this equates to eliminating 50 million tons of carbon emissions every single year. These figures represent a measurable shift in carbon mitigation, driven by the engineering of a single geographical site. The 179,000-acre footprint and the $2.2 billion transmission lines are inseparable from the 100,000 jobs they created. Khavda is a proof of concept for how global energy transitions are executed in the physical world. Solving the climate crisis is a massive engine for infrastructure development, capital investment, and economic empowerment.